All right, here's a tutorial video on quadrilaterals. Quadrilaterals are four-sided polygons, and a neat thing about them is all of the angles of every single quadrilateral, no matter what type of quadrilateral it is, the angles all add up to 360 degrees. So that's something that you can count on no matter what the quadrilateral is, and it is something that you need to make sure that you commit to memory because it'll help you find missing parts as we move forward. So again, quadrilaterals, four-sided polygons, all the angles add up to 360 degrees, four angles, four sides. Okay, a specific type of quadrilateral is a parallelogram. So the word parallel should really stand out at you because it's a big part of what the definition is. So it's a quadrilateral with two pair of opposite sides parallel. So two pair of opposite sides parallel, which it's going to bring in all kinds of characteristics. And you can see them listed here. So if you want to pause your screen and write those down, that'll be just fine. But just to be clear on what these characteristics of a parallelogram are is they're all as a result of having two pair of opposite sides parallel. So one of the characteristics is that opposite sides are congruent. So not only are they parallel, but they're also the exact same length. In addition to that, opposite angles are congruent. So for instance, like angle A and angle C are the exact same measurement. Consecutive angles, that would be angles that form same side interior angles, are considered consecutive. So A and B or A and D, those would be considered consecutive angles, and they are supplementary, which means their sum is 180 degrees. Then we've got these things called diagonals, and let me scoot up here so you can see a good picture of what diagonals of a parallelogram look like. So I've drawn another parallelogram here, and the diagonals connect opposite angles, so A to C and B to D. And in a parallelogram, the diagonals bisect each other. So that means they cut each other into two congruent pieces, making E the midpoint of AC and the midpoint of DB. So you can see how I've got it marked. AE and CE are the same. DE and BE are the same. Again, because the diagonals of a parallelogram bisect each other. All right, so those are characteristics that go with the parallelogram. And parallelogram is going to be really the foundation of what we talk about with most of our quadrilaterals. So if you know it's a parallelogram, all of these things are true instantly. All right, so here's an example with a parallelogram just so you can see how we would possibly give an example like that. Right here, CPHR, and then I named it just by tracing around it. CPHR is a parallelogram. If CH, which is that diagonal from C to H, is 28, find CK. Well, remember the diagonals of a parallelogram bisect each other. So that would mean if the entire diagonal CH is 28, then each of these pieces must be half of 28 or 14. Again, the diagonals bisect each other, so K would be the midpoint of CH, and it got cut into two equal parts, CK and HK. So 28 divided by 2, that's where we got the 14 from. All right, next piece. If PCR is 118 degrees, so angle PCR, and let me get rid of these 14s just to give us some more room here. All right, if PCR is 118 degrees, that's this entire angle here, P to C to R, is 118 degrees. All right, find HRC. HRC, that's this angle right there. Notice they're not going to be congruent. They are consecutive angles. In a parallelogram, consecutive angles are supplementary. So that means that these two angles should add up to 180. So 118 plus whatever the measure of angle HRC is should equal 180 degrees. So some of you already started to do this subtraction in your head. 180 minus 118 tells me what the measure of angle HRC is, which should be 62 degrees. So this total angle here is 62 because, again, consecutive angles are supplementary. then remember that opposite angles are the same. So this angle across should be 118 degrees, and this angle across from 62 should be 62 degrees, because opposite angles in a parallelogram are congruent. Well, look, they ask us what PHR is. P to H to R. Well, that's this angle here, and they're congruent, so this is 118 degrees. Now I'm going to talk about a quadrilateral that's not a parallelogram. So a quadrilateral that's not a parallelogram, that would be a trapezoid. So a trapezoid, again, not a parallelogram, it's a quadrilateral with exactly one pair of parallel sides. So if you look at my picture here of this trapezoid SHOP, only the opposite sides SH and PO are parallel. Now remember, parallel doesn't mean congruent, but it does bring in some angle relationships. So you have alternate interior angles supplementary, but not two pair of them. So angle S and angle P are alternate interior, but angle S and angle H are not alternate interior angles that are supplementary, because the opposite sides are not parallel, only SH and PO, not SP and HO. So again, I've got that written out here for characteristics for you over on the right side. Remember again, trapezoids are not parallelograms. All right, there is a special type of trapezoid, and it's called an isosceles trapezoid, and it's isosceles for the same reason isosceles triangles are isosceles. It has two sides that are congruent. So in this picture, hopefully you can see, according to the markings, that this is a trapezoid, one pair of opposite sides parallel, but then AD and BC are congruent, and that's what makes this an isosceles trapezoid. So it's a trapezoid with one pair of opposite sides that are non-parallel but are congruent. So the non-parallel sides are the ones that are congruent, and just like in a triangle, we call those legs. The characteristics of this trapezoid is that the diagonals are the same. So in addition to it being a trapezoid, you can add on that the diagonals are congruent. So AC is congruent to BD. All right, an example for an isosceles trapezoid here would be, all right, I've got this trapezoid, PAMP is an isosceles trapezoid. So right away, this opposite sides here are my parallel sides, and these opposite sides are my congruent sides. I also know that the diagonals are congruent, so all of these, now all the pieces are not congruent, they don't bisect each other, but all of PM is congruent to all of RA. So knowing all those things, let's work through A and B. A, the measure of angle M, that's this angle here, and the measure of angle P, that's this angle here, is the two pieces of information that they gave us. All right, now they want us to go ahead and solve here. Now I've got to be super careful, because one of the things that I need to mention is that because it's isosceles, it has a similar behavior with its base angles like a triangle does. So we actually can add to the characteristics that the base angles are congruent. So that means angle P is congruent to angle R, and angle A is congruent to angle M. All right, so we can add that in there. So I know that even though that M and P are not the same, I know that if angle P is x minus 10, then angle R is automatically x minus 10. And I know that if angle M is 3x plus 12, then I know that angle A is automatically 3x plus 12. Well, the angles of a quadrilateral add up to 360, so x minus 10 plus x minus 10 plus 3x plus 12 plus 3x plus 12 should all be equal to 360. And that's how I'm going to solve that. All right, combining like terms here. 1x and 1x is 2x, plus 3x is 5x, plus 3x is 8x. Negative 10 and negative 10 is negative 20. Negative 20 plus 12 is negative 8. Negative 8 plus 12 is positive 4. And that's going to be equal to 360. I'll subtract 4 from both sides. 8x is equal to 356. And I'll grab my calculator to find out what happens when I divide both sides by 8. X will be equal to 356 divided by 8 is 44.5. Okay, how about this next piece of information? And I'll try to clean up a little bit here. Get some of this extra info out so we can see everything okay. All right, so let's work through B. 28 minus x, that's what PM is. So that's this one diagonal, and we know that the diagonals are the same. So 28 minus x is PM, and then AR, which is the same as RA, is 6x. So that means those two things are the same. So I'm going to solve for x, plug it back in, and that'll help me get what MP is. So 28 minus x is 6x because the diagonals are congruent. So I'll add x to both sides. 28 is equal to 7x. So if I divide everything by 7, 4 is equal to x. Now remember, they didn't ask me to find x, they asked me to find MP. Well, MP is the same as PM, so that's the 28 minus 4 when I substitute in. So that'll be 24.